Welcome back to the wonderful world of quadratic equations. You know, quadratic equations are so important nowadays in describing what's going on. You throw something up, it goes down. But you notice that the shape of its path was a parabola. And that parabola can be described using a quadratic equation. They talk about peak of coronavirus. The peak is the top of a parabola, all right? And people are working furiously to model that curve. Is it flat? Is it up? When is it going to peak? That can be modeled if you understand what's going on with quadratic equations. So this is just another part of this whole picture of quadratics, all right? We're trying to keep all this quadratic stuff in one particular section of your notes so that you can focus in on just the idea of quadratic equations in this chunk of math. All right? So today we talk about a small piece of quadratic equations that determines how many possible solutions you could have. And it turns out that's a good thing to have. Are you going to get two solutions? Will it cross the x-axis in two places? Will it only touch it at one place? Or will the parabola be floating above or below the x-axis and not even touch it and get no possible solutions? That's what we're talking about when we talk about something called finding a discriminant. A discriminant is a way to find the number of solutions in a quadratic equation. And your possibilities are 2, 1, or 0. So how do you know? Well, we deal with this thing called a discriminant. You will recall that the quadratic equation form ax squared plus bx plus c equals 0 is still in place here. And a is whatever's in front of the squared term, b is the number in front of the x to the first power term, and c is just a number, constant. All right? So to find the discriminant, we use this weird looking formula here. B squared, that's this b, minus 4ac, ac. Yeah, as it turns out, in our next lesson, the quadratic formula, you're going to see this b squared minus 4ac again. Just a little hint, all right? And actually, we've skipped ahead of the quadratic formula to this so that you can get used to a part of it right now. So we're going to use this idea of a discriminant formula, b squared minus 4ac, all right? So why do we do that? Well, watch what happens. We've got a quadratic formula, 0 equals x squared minus 4x plus 3. If we were going to graph it, we would see that the graph would look something like this. An upward parabola, right? A is positive, so it's going to open upward, all right? And it would cross the x-axis in two places, so we would say there are two zeros, or two roots, two solutions to this equation, all right? Well, we could have done that without graphing, because we know how fun graphing is, right? Yeah. So if we take advantage of the discriminant formula, right, b squared minus 4ac, and try to find what value is that. So I look b squared, all right, b here, right, is minus 4, so empty parentheses, minus 4 squared, minus 4ac, a, the number in front of x is 1, c, the constant at the end of this thing is 3, and we do the math, minus 4 squared, 16 minus 4 times 1 times 3 is minus 12. 16 minus 12 is 4. We say that 4 is the discriminant of this quadratic formula. And the number itself really isn't all that important, 4, 5, 6. All say the same thing because notice that the discriminant here is greater than 0. And we see that when the discriminant is positive, when you have greater than 0, we will have two roots. Let's look at another example. Here, the equation x squared minus 4x plus 4. We find the discriminant, b squared minus 4ac, b squared, b minus 4 squared, minus 4a, 1c, 4. We do the math, 16 minus 4 times 4 minus 16, 16 minus 16. The discriminant is exactly 0. If we were to graph this, it would look something like this. And you would see that there is one solution for x, where it hits the x-axis, 1. Which gives us a clue that when the discriminant equals 0, we have exactly one possible root. Let's look at another one, our other example. X squared minus 4x plus 5. We do the discriminant formula, b squared minus 4ac, and get 16 minus 4ac minus 20. The discriminant here is negative 4. All right? If we were to graph this, it would look like this, and we would see that the graph of this does not touch the x-axis, and therefore there are no roots. And so what do you know? When the discriminant is negative, there are no roots. Now again, we're just looking at the discriminant as far as is it positive, is it 0, or is it negative? The number itself, 4, 5, 6, minus 3, minus 2, minus 8, we're just looking at the minus, plus, or 0 aspects of this discriminant. So we can put this all together in using the discriminant, a value, when we have the value of b squared minus 4ac, and that determines the number of solutions to a quadratic equation. If b squared minus 4ac is greater than 0, your discriminant is positive, then you're going to have two solutions and the graph will intersect the x-axis in two places. If b squared minus 4ac is less than 0, if the discriminant is negative, then there will be no real solutions. And it does not intercept the x-axis at all. And finally, if b squared minus 4ac is exactly equal to 0, then there will be one possible solution where it touches the x-axis in one point. All right? So you'll see things like find the discriminant. Well, all right. Recall we're looking at b squared minus 4ac. So empty parentheses squared minus 4, empty parentheses would be a good way to start. We figure out b is minus 3, that goes in here. For a is 1, and c is 9. All right. And so minus 3 squared, 9 minus 4 times 9 minus 36. And so the answer minus 25. Then we have a negative discriminant, and so there are no solutions. There are actually no real solutions, all right? Yeah, no real solutions. 27, yeah, sorry there. But 25, 27, that's not really the answer. It's just, did it turn out to be positive or negative? I didn't even have to do the 9 minus 36. I knew it was going to be negative. So for this particular quadratic equation, there are no real solutions. Okay. What about this one? Well, once again, parentheses squared minus 4 parentheses. And we just have to figure out what's a, b, and c. Well, here, b minus 3. Here, a now becomes 2, and c is minus 4. So we get 9 minus, we got minus 4 is plus 16 times 2, 32. All right, plus 32, I should say, right? 9 plus 32, well, I don't even need to do the adding here to get 41, because that's going to be a positive amount, right? Minus times minus gave me plus 32. So here you say that there are two real solutions, right, for that particular equation. Something like this, well, again, parentheses squared minus 4 parentheses, all right? B is 8, A is 1, C is 16, 8 times 8, 64, We got minus 4 times 16, oh, what do you know, 64. And the discriminant is 0, and that tells us there are 1. It's a real solution. So that's how you use the discriminant formula, all right? In real life, you might want to know whether something's possible or not, all right? You're going to throw a ball up at 20 feet per second, some velocity. You're 5 feet off the ground when you throw it, right? So my ball here is 5 feet off the ground. I'm going to throw it up into the air, and I want to know if I'm throwing this up in the air, will it get to 30 feet in height? Can I, say, get it up on a 3-story building or something like that if I throw it that hard? Well, the formula, physics gives us these parabola formulas, all right, which says the height that the ball's going to go depends upon minus 16, the time it's going to be in the air, and the velocity and the height above the ground. Well, you might recognize this as a quadratic formula, and it is. In this case, they give us h. They say h is 30 feet, all right? And rather than try to figure out how much time it's going to take, solve for t, let's just find the discriminant and see if it's even possible. So we substitute in 30 for the height here, all right? And we've got this quadratic equation. We want to set it equal to 0, so I'm going to subtract 30 from both sides, and I get 0 equals minus 16t squared plus 20t minus 25, right? Plus 5 minus 30 gives me the minus 25. And now I find the discriminant, all right? b squared, 20, minus 4a minus 16, and c is minus 25. I get 400 minus 1600. 400 minus 1600, I don't need to know that minus 1200 is going to be negative, and there are no possible solutions. The ball ain't going to make it 30 feet high. That's what this tells you. Don't have to waste your time if there's no solutions possible, right? So there's one use in physics for finding that, and it is rocket science. That's what they talk about, the path of a rocket going up and down, that type of thing. Sometimes known as gravity's rainbow, up and down, described in quadratics and simplified by using the discriminant. So, give it a try. Lesson 113, do A to D, 1 to 2, and 5 to 6. Right. And then we'll have, as part of the second part of this week's stuff, all right? This is going to be the only video for this week, and it's the only lesson for this week, because if you look on the website, you're going to see an investigation or some kind of a task, worksheet 11. And that's going to keep you pretty occupied there. It's what we call a rich math problem that will test your work on finding areas but dealing with quadratics at the same time. So we will talk to you later, and keep up the good work.